Hey everyone, and welcome. Today we're going to peel back the invisible layers of the very thing that makes our digital world tick, software. We're going to see what's really happening inside your phone and your computer every single time you tap, click, or swipe. All right, let's dive in.
So just think about that for a second. You tap a little square on your screen and boom, a whole universe of information, connection, or entertainment just opens right up. It feels like magic, doesn't it? But it's not. It's a super carefully constructed, multi-layered process. So the big question is, what exactly is that process? This right here, this is our map. It shows the 4 fundamental layers that sit between you, the user, and the raw computer hardware at the very bottom. This is our roadmap for this entire explainer, and we're going to journey down this stack, from the top all the way to the bottom. Okay, so here's the game plan. We're going to start with the really foundational stuff, the software that's closest to the actual hardware. Then we'll look at the operating system, the boss, that manages everything. After that, we'll get to the apps we use every day. And finally, we'll put it all together to see that full, amazing picture. All right, first up, system software. This stuff is the real unsung hero of your computer. You could think of it like the stage manager in a huge theater production. You never actually see them, but without them, the show just, well, it can't go on. Now, here's the key thing to get about system software. It doesn't do specific tasks for you. It's not your word processor, it's not your web browser, it's not a game. Its only job is to manage the computer itself and create a stable, predictable environment where other programs, the applications, can actually do their thing. And this table just lays out the differences perfectly. See, on one side, you have system software. Its purpose is to operate the hardware. It talks directly to the chips and circuits. That's why it's written in what we call low-level languages, because they give it super precise control. But then you look at application software. Its whole purpose is to do a specific task for you, the user, and it runs on the platform that the system software provides. They're a team. One absolutely cannot exist without the other. Okay, let's clear up a super common mix-up here. It's really easy to think system software means it came with the computer, and application software means you downloaded it. But what about the calculator app on your phone or the Notes app? You didn't download those. They're still applications. So the real defining factor is the software's function, not how it got onto your device. All right, now let's talk about the rock star of system software, the one everyone's heard of, the operating system, or OS. If all the hardware components, your processor, your memory, your graphics card, are a giant orchestra, then the OS is the conductor. It's the one making sure every single part plays together in perfect harmony. And believe me, this conductor is busy. The OS is constantly juggling all these critical jobs. It's deciding which program gets to use the processor right now. It's allocating memory, it's organizing all your files, and it's even creating the user interface, the windows, icons, and menus you click on every single day. So here's a good question for you to make this a little more real. We all know that modern solid-state drives, SSDs, are way, way faster than old-school hard drives. So why is it so important to install your operating system on the absolute fastest drive you've got? Well, the answer is actually pretty simple. It's because the OS is being used constantly. For pretty much anything you do, opening a file, launching an app, anything, the computer needs to read files from the operating system. So putting those files on the fastest drive just makes the entire system feel snappier and more responsive. It's a small choice with a huge impact. But the OS isn't a solo act. It's got helpers. And think about this for a second. You go out, you buy a brand new printer, you plug it into your computer, a device your computer has literally never seen before. How does the OS, our conductor, suddenly know how to direct this new musician? The magic behind that is something called a driver program. It's another type of system software. And the best way to think of a driver is like specific sheet music for that new instrument. The OS, our conductor, gives a general command like, print this page. And the driver translates that into the super precise instructions that specific model of printer can actually understand. And you need these drivers for pretty much any piece of hardware you plug into your computer. Things like printers, scanners, webcams, you name it. We call these things peripherals, and they almost all need a special driver. And then you've got one more little group of system helpers, utilities. Think of these as the system's maintenance crew. They do all the important housekeeping jobs, like checking for viruses, managing files, and just generally keeping everything running nice and smooth. Okay, so we've got our foundation laid, our conductor is on the podium, and the maintenance crew has cleaned everything up.
Now it's time for the star of the show, application software. This is the software you actually came to see, the solo performance that lets you write that essay, edit that photo, or browse the web. So remember how system software was all about running the computer itself? Well, application software is the complete opposite. It's all about a specific purpose. Its entire reason for existing is to help a user, you and me, accomplish one particular task. This is the software we actually interact with. Now, this is a really important detail. An application can't just run anywhere. It has to be specifically written for the operating system it's on. That's why you have to download a Mac version or a Windows version of a program. Even if they look totally identical on the outside, underneath they are speaking a completely different language to their OS. And that brings us to something we all deal with: updates. Why on earth are we always updating our apps? Well, it's not just about fixing bugs, even though that's part of it. Updates are absolutely crucial for adding brand new features and for optimizing the code to make the software run faster and more efficiently. All right, we've met all the players in our orchestra. We've got the system software foundation, the OS conductor, and the application soloists. So now for the grand finale, let's bring them all together and see how they perform a complete piece, the software symphony. So let's go all the way back to the beginning. You tap an icon. That's the signal. The application software wakes up and asks the operating system if it can run. The OS, our conductor, immediately jumps into action, allocating memory and processor time. It then takes the application's requests and translates them into low-level instructions that the physical hardware can actually execute. And all of this happens in a fraction of a second. It's amazing. And just like that, that's how it all works. A beautiful, invisible collaboration between all these layers of software. But here's a final thought to leave you with. As software gets smarter and smarter with AI, will these distinct layers we've talked about start to blur? Will the OS of the future start making decisions for us, kind of blurring that line between a system tool and an application? Something to think about, right? Thanks for joining this explainer.